Okay, who is anti, who is gauge?
Left is anti.
Okay. And who has a lower energy?
Anti. Wait, large energy.
Okay, lower.
Yeah, lower is anti.
Lower is anti. Okay. Do you? It's kind of like obvious. I saw this one because anti is the largest group. It's in the opposite.
Is it because it's the most symmetrical? Like.
Doesn't mean symmetrical. I want. Okay, this can be something a little bit large than hydrogen, but I want the largest group to be the opposite. Okay. Okay. If you're okay, it's still 60 degrees to each other, but you will still have some strain. Strain means they're too bulky, they knock into each other, they don't like each other, okay? Yeah.
So I have like an answer key that is like quite conflict to like separate the largest.
Okay, show me what you have.
It's like this is the question, the D, and the problem is like circle the most stable one. So it's like, oh sorry, it's
Yeah, okay.
And so it's like this one is like, I think we should separate like this group and this group because it's quite large, but the answer like choose the opposite one.
This one, I'll choose this one. The answer here is wrong then.
Oh, okay.
Okay.
Okay, thank you.
Okay. But I do need to, so it's not something you need to know right now, but it's good to if you know this, okay? So straight chain, okay, straight chain. It's not on your midterm one, but I still think it's a good thing to know, okay? If it's straight chain, it's not as bulky as okay, let's say this one. Okay, even this one only have okay. This one only have 4, 1, 2, 1, 2, 3. This one even have 3 members, but can you imagine crowdedly they were just like this? Well, straight chain, I know I have 1, 2, 3, 4, 5, 6. I have 6, but they were still a little bit slim in the first several steps. So even this one has more, we will still consider this one has smaller steric hindrance. It's not simple. It's not just like a hose. There's 6 carbon, then that's bulky. It's not. Doesn't work like this way. This is also have something to do with later in chapter 6 and 7. You will learn something called a bulky base. Okay. I know it's too early for now, but it's not going to be not going to be on midterm 1. We only ask you. I know people are confused with acid base. Okay, later in chapter 7, we will talk something called bulky base, which the bulky base is the only 2 bulky base. Okay, the only 2 bulky base you are likely to see in 118. Okay. So this is what we meant by steric hindrance. It's not simply by how many carbon you have. It's more of like, okay, that's really crowded. And that's crowded, okay? Are we good with that? This is bulky. And then when I said bulky, your largest group or bulkiest group is in the opposite way of each other, doesn't mean it just have more carbon number. Are we good? Yes?
So like for a straight carbon chain and compared to like hydrogen, it's still considered like.
Oh, the hydrogen always have the smallest one.
Okay.
Okay.
For Newman projections, do we need to know how to like take a structure and put it in the projection, because that's what we did in discussion, or do we just need to know which is the lowest? Like.
Okay, for midterm 1, which I only set a question on, you need to compare, you need to know anti, you need to do. Taking 2 things into consideration. 1, you guys are like either standing or writing on a pad, which is hard to write. 2, it's your first time doing Newman projection. You probably haven't really got enough practice of that. But you are expecting finally you will be able to draw Newman projection either in midterm 2 or final. Are we good with that?
Thank you.
Okay. Are we done with Newman projection? Yes?
Just to confirm for this midterm, we only need to know anti and gauche, like what kind of structure and strain it is.
And eclipsing. and eclipsing.
Yeah, but like, do we only need to know like those strains and stuff, or do we need to we need to draw it, right?
Okay, in midterm 1, I'm not expecting you to draw it. I'm expecting you to know who is who. Okay, are we good?
Yeah.
Okay. But that's only for midterm 1. Later, you will still finally like need to know it. Are we good? Need to know how to draw it. Are we good? Okay. Any more about Newman projection? Yes?
If you had two bigger substituents, like on the back carbon, like you had two methyl groups, would you
you
still
mean-
use the
you mean-
same
you mean-
terminology?
Like this one?
Yeah, or if like one of the that H was also like a CH3.
This one?
Like if the one on the back had two circles,
Oh, 2 3.
two methyl groups, like H
Okay, I
and
see.
then CH3. Would you still use the anti-Gauss
But
terminology?
But if it's like this, okay, if it's like this, they would be eclipsing, right? Because they're knocking into each other.
I meant like if you replace one of the hydrogens with another methyl, CH.
This one?
Maybe I think that it's Andy and Gauss just like mentioned about stagger and eclipse. Maybe like you didn't need.
And
Yeah.
you were in the staggered with the two methyl groups in the back, would you still use any anti?
So is that in this format or in this format that you're talking about? So do you want still 60 degree of each other, or you want right knocking each other? So
the staggered?
okay, this stagger. Okay, now which one should I change?
Maybe the bottom hydrogen.
Okay, maybe the mountain into CH3.
Yeah.
Okay, then it's going to decide on what specifically this group is. If this is a bulkier group than this one, then it's a gauge. If it's
Okay.
so anti is always your largest group is in the opposite direction. Are we good?
Yeah. Thank you.
Okay. Are we good? Any more on Newman projection? We're good? Okay.